Hello, everybody. Thank you for coming. We are going to talk about how to manage the quality in Kubernetes and explaining how the graduation process goes from alpha to GA. My name is Antonio Gea. I work at Google.
Hi, I'm Benjamin Elder. I also work at Google.
Okay, we are both of the SIG testing TLs and members of steering. And for all of you that know Kubernetes, you may know how Kubernetes works. Kubernetes is an important open source project with a large ecosystem, right? It's not only Kubernetes. You've been here, you go to the booth, you see, I don't know, how thousands of projects depend on Kubernetes, right? And to handle the development of this project, the way we are organized is technically we have special interesting groups, right? So each group can be horizontal and handle things like API machinery or CLI, or can be vertical, like networking or no. But what is more important for the project and for the users is the project needs to keep growing, need to keep evolving, right? And this means adding new features. So I don't remember when this started. We are very large and we need to get organized, right? So the way we organize the new feature development is via KEPs, right? So the KEP process it can be a bit heavy for newcomers or for users, but it has a purpose, right? It has the purpose of communicating across SIG. So everybody can look at the place, oh, I'm proposing this. Because it's impossible to understand beforehand all the radius that your feature is going to have. So it's important that we have a center point to communicate with all the features. And also to be transparent. We are an open source project. This is about community, right? If I want to add something, I need to get feedback from the other SIGs because you don't work in isolation. We try to break all the silos, so there is no network, there is no node. There is people that is interested in node that may work on network things, and people that is interested in network that may work on all things. So let's deep a bit more into the KEP process, right? So when you want to add a new feature, then you need to consider what is going to be the life cycle of this feature, right? We have 3 stages that are alpha. The expectation of alpha is, okay, I have a feature, a proposal, I know more or less how this is going to work, I discuss it with the SIGs and all the stakeholders, and I wouldn't say a prototype because we want alpha to be usable, right? People can try and should work. It should work, no, it must work. But we understand that alpha has, it's impossible to know everything beforehand, right? We need to allow innovation. So we cannot be forever trying new things or prototyping or getting feedback. So the quality bar for alpha is a bit lower. Then we move to beta. In beta, we have a more, how can I say, a stronger requirement for stability, right? If we have a feature that is beta and doesn't depend on APIs, this is going to be enabled by default. That means that every Kubernetes user is going to run their cluster and is going to have your new feature running. So when something is running, it means that there is already a contract with this end user, right? We cannot break them. But they still know that we are not fully getting the end details of the feature, so we may have some room for improvement. So they need to be aware that some things can change. And then after beta, we move to GA. In GA, we have a strong commitment with the end user and with implementation. And this is one of the key points of Kubernetes, right? We have a very high quality bar, and this means that we can have an ecosystem that depends on our features, right? You develop something in one version against a GA version, and I mean, we are not perfect, we fail, there are bugs and there are things, but I think that we are doing well on our stability of GA features. And we talked about features, but you see one of the strongest points of Kubernetes are the APIs, right? Most of the features depend on the APIs. The key of the APIs is that allow to provide contrasts with all these 1,000 projects that depend on Kubernetes, right? So you don't need to absorb all the problems in Kubernetes. You can create the right interfaces, define the right semantics, and allow all the ecosystem to grow based on your interfaces. And that's why it's important, and you see that if you go to any API review or you have a new feature, there is a group of people that is specifically attending to this. APIs are very sensible and very critical, and we invest a lot of that. But most important that I want to highlight, APIs are not just for defining the syntaxes, right? I'm going to put this field or whatever thing. It also defines the interactions with the other component, right? And it defines what the system should do. It's not only to define the fields, you need to define how it's going to behave, because people expect that when you add some field or when you set your YAML manifest in a certain way, the system is going to react in a certain way. And this is what provides interoperability and portability. That's one of the biggest success of Kubernetes is that you get your Helm chart, your YAML, you apply in one cloud and runs in the other cloud too, right? Because we have strong APIs with clear defined behaviors. But here is when the problematic starts. We talked about features, and now we talk about APIs. The problem with APIs is that if the APIs are beta and are beta forever, it's hard to graduate them, right? So since, I don't remember now which version, 121 or 122, all these beta APIs are disabled by default. And as a consequence, all the features that depend on beta API are disabled by default. So we start to see a bit more on the problematic of feature development, right? So now you have features, but you have also APIs. And we need to be able to graduate both at the same time to offer stability. But we also talked about, Benjamin is going to dig a bit deeper later on these topics, but we talked about KEP. We talked about the feature gates, and we talked about the APIs. And in the KEP process, some years ago, we started to find gaps in our stability, right? We were building a lot of features, and then the system was unstable. I don't remember, in 120, 123, we have a lot of flakes in the CI, right? Things didn't work. Why? Because we had a lot of features, but the system was not stable. We have kind of, this is a joke, but most of you that work in software development, I'm sure that you work in projects like this, right? So we have now the production readiness group. That's the one that when you go with the KEP and you want to move to beta and to GA, they start to ask these hard questions. What happens if? How the end user is going to control this? Just this running 1,000 nodes, what are your scalability requirements? So this is an important process, an important group that the project put in place to control that when we release something, it's production ready. And production ready means you can run it and have your business on top of your features. And well, all these steps are needed to guarantee a quality bar. We want a high quality bar for the project, but we know that the quality bar has to be adapted to the development because we need to innovate and we need to keep the core stable. And for achieving both things, we need to face this, right? That's why we have these different stages and different criteria. And then how we enforce this? Well, I think that's in the next slide. We enforce this with testing. So we have different test suites, right? We run kind of a pyramid, but it's a metaphor. We don't want to get into technicalities, but we have a strong suites for unit integration and E2E tests. And we have the suite of tests that is called conformance. The whole point of this test is that integrations and third-party projects can build application depending on the APIs and the behaviors. That's why it's important. I said this several times, and I will not stop saying it. We need to guarantee portability. We need to guarantee that application works in different Kubernetes versions and different Kubernetes installations. And that's why it's so critical, this suite of tests. This is the minimum necessary that we consider for a Kubernetes cluster to run portable applications. Okay. How we enforce this? Well, I touched on this before. We have a lot of, we spend a lot of money in CI. I don't know. And we run a lot of tests. And we invest heavily in automation. And we rely heavily on SIGs. If you think in the traditional software development, there is no developer, QA, and other people. This is how can I say? There is a shared responsibility. Thank you. A shared responsibility, right? It's not that this is my feature, this is your feature. This is our project, and we need to take care of that, right? And it's our project, and I'm responsible of this feature or of this area. I need to be accountable of this area. How we enforce this? We really don't enforce it. There are different groups of people that everyone adds the value. There is a group on SIG release CI signal that monitors some specific tests that when something fails, just warn the responsible of the job. There is people in the SIGs that are responsible of fixing these jobs. And we work as a community. And I think that one of the most proud things that I'm of this project is that we have a zero flake policy. So we don't allow tests to flake. Why? Because if a test flakes, you don't know if it's working or if it's not working, if it's your code or what it is. And we have a strong commitment with this, and we have also this written in our policies. We don't allow flakes. Over to you, Ben.
So the SIG testing special interest group is dedicated to Kubernetes testing. You've heard about this a bit. We, to be very clear, don't own the tests. That's the shared responsibility. That's not scalable. There's so much complexity in all the different parts of the project. To have one central group own all those, it doesn't make sense. But what we do own is the testing infrastructure, the standards, the frameworks, the best practices, and working with all the SIGs on that. So why are we giving this talk now? Why are we making some changes to improve this? Pretty much DRA. I'm looking at Patrick here as one of our also SIG testing TLs who's been working on DRA. DRA makes this problem a lot more interesting because we have multiple alpha features that depend on beta features, and there's a huge demand to graduate quickly and get this functionality available for all these people that are running all these huge clusters with accelerators and need more flexible scheduling. And it is a lot more complicated to understand how are we testing this correctly, where can we run these when it maybe depends on various things. So we'll talk a little bit more about that. So when we're testing a feature that you've been developing, a KEP, the unit tests are like fairly self-explanatory. You have the scoped piece of code that's part of implementing it, and you're controlling running that code, and you write test cases for it. Pretty standard. Same thing for the integration tests. Are a little weird. Ours are a little weird, but the integration tests themselves are standing up the environment, so you know exactly what the API server looks like because you just started it. When we get to end-to-end tests, it's a lot more complicated. We mentioned earlier that there's a conformance suite. Well, that's part of it. We have a test binary that needs to be able to point at different clusters. It's not really feasible to totally couple the end-to-end tests with each of the cluster environments directly. So when we get to end-to-end tests, it is totally separate that we're bringing up some kind of cluster and then we're trying to run tests on it. And we need to know, wait, can I run this DRA test case or not? Is it depend on an alpha feature or beta feature and so on? So in the past, the main way that you would tag one of these tests with a framework is you would just say, well, it has a feature. And feature is a super nebulous thing. And it would get inserted as sort of like a pseudo tag in the generated test name with the rest of your like handwritten test name, and it would be in braces and say feature, and then the name of the feature you gave. And this is just an arbitrary string. And it could mean that your test depends on having a load balancer installed. It could mean that your test depends on having a feature gate turned on, or it could mean that the test depends on the cluster being configured in a certain way. Like we're going to test the dual stack logic, so the cluster needs to have dual stack enabled and not be a single stack cluster. So this is really heavily overloaded. So what you would see is most of the CI jobs would just skip anything with any feature tag. Like, I didn't do any special setup. I'm not dealing with this. And if you're building a feature, then you're going to go make sure that you have something that instead says, I'm going to run things that match this feature. And it just doesn't scale very well. You're pretty much on your own to figure this out. And you can talk to us, but there's no shared system, really. Patrick here did some work a while back to make us onto Ginkgo v2 with some other members of the community, which also got us access to Ginkgo labels. We hadn't adopted them very much yet. Ginkgo labels, with the test framework we use, they allow us to move metadata about the tests into selectable labels that aren't crammed into the test name. You can actually query them, as we'll come back to, and you're not just doing a regular expression that's include and exclude. So you can actually say, you know, I want to run certain things. So we've in 133, towards the end of the release, we were finished, we tweaked this with feature gate method. So now, if your test just is testing a feature gated feature, you pass with feature gate and you pass the actual standard feature gate definition. And I wrote here, you may not be familiar with this. In Kubernetes, there is a centralized registry of features that can be enabled across all the components. And so there is like a package that has all the features, they're named, they have a bunch of metadata about them, like who owns them, and centrally approved. They have the state, alpha, beta, GA, if they're on by default, and so on. So you can now actually pass to the E2E tests, this is my canonical feature metadata, and it can annotate the tests with the information about the feature stability level, whether it's turned on by default, and so on, the feature name. And no more horrible broken regexes trying to select the right tests. So you now say, my test depends on this feature gate, and that information is there. You say, my test depends on this feature, like special setup, installing a controller. Or in the case of DRA, it depends on both. We need to have a DRA driver installed because there isn't a standard driver. It's for whatever device you want, whatever you're allocating dynamically. So you need to have the dynamic allocation features turned on, and you need to have the dynamic allocation test feature, which is signaling that there's some extra setup required before it can run on a cluster. So you tag it with both. And so this is what I was talking about. This is the metadata we pass through. What we are doing as part of this is setting up some standard CI jobs that will run all of the tests that just need to turn on that feature gate and skip the ones that require extra things. So for a lot of features in the project, they're doing something like declarative validation. That is a totally server-side feature in the API server. It doesn't have any external dependencies. It just needs to be turned on because it's not at GA yet. And to test that, all they'll need to do is annotate this. And so we will be really pushing the feature approvers to say, you should not be promoting features that have no tests or are being hand tested, as may have happened in the past. There will be an expectation that you definitely have CI all the way down to an alpha feature, even if it's brand new. We need to know that it's working. If it's totally broken, we shouldn't be shipping it to users. And it definitely shouldn't be promoting to beta if it doesn't have reliable tests yet. So when we're doing this, we're basically saying, okay, this cluster, we're turning on all the alpha features. We're turning off evented plague because that's one of the features that had promoted further, turned out it wasn't stable enough, needs quite a bit of work. But hopefully going forward, we're just turning on all the alphas. We're turning on all the alpha and GA APIs so that you don't have to worry about that distinction. In CI, we're standardizing on, we turn on alpha and APIs and features at the same level, beta and so on, makes it a little bit less confusing to think about. And then we can write this query that basically says if it has a feature that it's an off by default feature gate, or it doesn't have any other feature information, we'll run that. If it's not a beta off by default, because we're doing alpha tests, and if it's not a deprecated feature, because that's another feature level that we didn't talk about, some extra complexity there for basically, here's a way to toggle something that we're removing. For one more release, you can turn it back on, but it's going away. And then this slow disruptive flaky is sometimes when we're working on tests, we've kind of kicked them out or said this is slower. We're going to iterate some more on that, but basically there's some categories of like, these tests are known bad, and we're not able to fix them quickly. Let's make sure that they're not blocking pull requests until we get that sorted out. If you have a feature like DRA, you still got to work with us to set up some CI for that, but that will be a diminishingly smaller set of features, and we will expect to keep up and have that for everyone. Also, let me come back to this one. Where did that? So one other thing that happened here as we were working on this is we actually found that while the Kubernetes feature policy says alphas must be off by default, this wasn't enforced, which made this problem a bit more complicated and also means we're not communicating things clearly to users. There was, in fact, a feature that was on by default since 126 that was in alpha quality and is going away in 133. Hopefully it's fine. Most of you probably won't run into it. It relates to host network on Windows. But now we have some tooling in place that you can't do that. It won't block the pull request if you try to set on by default and alpha. That's an inconsistent statement to the user. So that simplifies how we communicate on the test to make sure we're shipping the right quality bar to production. And this is the kind of thing that we're working on to make sure that going forward, we're 10 years in the project and still having features that are partway through the life cycle being hand tested locally just isn't good enough. And so this is an example when you have a feature that you do need to do extra setup. And so we're saying it's allowed to be tagged as it requires this extra dynamic resource allocation setup, or an off by default feature because we're going to turn all of them on to run this because this has alpha and beta features. We've turned on the alpha and beta APIs that we need, and we're ignoring the flaky tests until we've gotten that sorted out. And there's some extra bit here that isn't inline because it's some fun bash that sets up actually having a mock DRA driver. And this runs on a kind cluster, which is another SIG testing subproject. And these are pretty copyable. So if you have a relatively simple one where you need something like a load balancer or a driver for a dynamic resource, we have little local implementations. You just need to make sure that if you're testing that we've taken this DRA job, made a version that installs the load balancer instead and runs your load balancer tests. And we're doing that. So we'll be putting out some more comms in 134 early in the release cycle. Kubernetes is about to ship 133 shortly after KubeCon. And we'll be making sure that everyone who's contributing in the community knows about these changes, knows the expectations to adopt them, and the increased expectations on not just the written quality bar that we've had, but actually making sure that we've provided the tooling and the shared resources to execute on it more easily. And that includes getting more of the signal into release blocking and pull request blocking. We actually want to go as far as to say even just turning on an alpha needs to be blocking releases, not the tests. We know people are just getting started iterating on those, but we'll have that signal running somewhere so it can block promoting them to beta. And pull requests should start blocking on beta APIs consistently. That's not actually guaranteed today. Make it a lot harder to have regressions with these earlier in the process. Kubernetes used to lean a lot more heavily on stability in GA. We're bringing more of that back down to beta and even down to alpha, that even an alpha feature shouldn't make GA features unstable. Thanks. Let us know if you have any questions. Come join us in SIG testing in the Kubernetes Slack. Yeah.
How long does a typical feature take to run all the test suites in CI?
For a given, like one feature?
Yeah.
That's really hard to say. They're all over the place. For some features, we need to run scale testing. We need to make sure that if you make some scheduler changes that you haven't regressed the performance on large clusters. And some of those test runs take 12, 14 hours, 5,000 node clusters.
Wow.
So there is, when we talk about this, there are two stages, right? Pre-summit, that is, we don't want this thing to merge, and we have kind of a line of 1 hour to run. So you get signal, right? You're developing, you're sending something, and you want to know, I'm breaking something or not. So we have kind of a hard line in 1 hour. It's not exactly, but we try to keep that. Then we have a lot of tests that run in periodic jobs, right? And then there are like scalability tests that run every 2 or 3 days, and that's, I don't know, 1,000, 5,000 nodes that can take longer. But usually for developers that want to submit something, we are tend to get about of 1 hour for getting feedback.
We also have a 2-hour bar for release blocking signal, and then we have some release informing signal that's like the release team should look at this, but it's not a guaranteed blocker. Also, to be clear, we're talking about like a whole suite. We generally don't want to have like a CI run that we have to do for like a specific feature. There's some overhead to just like compiling Kubernetes and bringing up a cluster. Even when we're running with Kind, we have to throw a decent number of cores at just building Kubernetes in a reasonable amount of time. There's a lot of code. So typically these are shared suites, and individual test cases are expect to be pretty fast normally. But Kubernetes has thousands and thousands of test cases to cover all of everything. So it really depends on the scope of the feature.
Okay, thank you very much.
Hey, can you expand a bit about the zero flakes policy?
Okay. Yeah, we did a talk about that last time. Okay. So, if anybody spots a flake, we are filing a bug. We are assigning people that are working on that feature. The community is pushing to fix that. It takes an initial push to get to a place where things are pretty reliable, so people aren't used to flakiness. And I think we've achieved that. So now that people aren't used to flakiness, the community is pretty good about, why is this thing failing? It doesn't seem related to my change. We also have a lot of tooling for this. We have this system called Triage, go.k8s.io/triage. And we basically run a pipeline that does KNN clustering of failure messages across all of the CI jobs. So you can say, I have a graph of over time, this error message started cropping up more. So we have some failure mode with like starting up a pod or something, and you can prove that maybe it only failed once or twice in a PR job, but there are 10 other periodic tests that are also hitting it, and that graph has spiked, and there's a button to collect that information, and you can just like file an issue with all that. And the release CI signal team also works really hard on this for all of the release blocking and informing signal to make sure that the moment one of those crops up, we're tracking it, we're fixing it, we're removing it. The flaky tag you saw earlier was more of how we handled in the past. We would just go, okay, we got to kick this test out. We still have some, but we've also been eliminating those.
There is also a cultural thing, right? So before we had these Gingo flake attempts or something. No, so if eventually pass, it goes great. We remove that. The test pass or doesn't pass. Then
Yeah, but that is the easy one. Like, when I say zero, it's zero. It means that if it flakes one, then you have to chase it.
And then that's what I'm saying. Then we have a strong community position on this, right? So you have the release team. When they see that this periodic graph, flake, they open the bag. When there is an investigation, it can happen several things, that the test get fixed or that the test get removed, right? So that's the thing. If you keep the flakes going, at the end you are going to have a lot of flakes. So you need to take a decision. I think that in my experience in all the other projects, this is one project that takes this decision, right? Or you can get your feature out. If you have a feature that is flaking, and it happened, it was flaking, it was beta, and nobody did anything, so it got demoted to alpha. So when you start, when the project has this position and this strong commitment to quality, then everybody starts to absorb this behavior, right? And then it's when you, in the late run, are able to have a more stable CI, because the person that developed the feature is also aware, right? And it's not that I'm going to drop my feature and leave. It's I'm going to drop my feature, I want my feature, and I'm going to take care that my feature is stable.
I think to get there, though, we had to make a pretty big push around this and look at like what are sources of flakes, get rid of the systemic sources of flakes, like noisy neighbor problems in CI, get that cleaned up so there's no excuse. It's like, oh, the CI is making my test unreliable. No, your test is unreliable. And then burn those down. And then get people used to, okay, we're no longer doing flake attempts, and we have a bot that auto posts retests the CI when it fails. None of that's going on. It passes or it doesn't. Get people used to that so that it actually feels like an outlier. And then it's a lot easier to get buy-in from all the developers that, yeah, we should address these. When they see lots of flakes, it's really hard to convince people to work on it. I think we're at time. Thanks all.